Bismillahirrahmanirrahim. Dear students, I hope you all are fine and in the best condition of your health. So, in continuation with the lectures on medicinal chemistry, today we will consider about the second lecture, and here we are to discuss about the introduction to drugs. Right. So, in the previous lecture, we studied about the macromolecules, and we saw that macromolecules are basically of 5 types. So these include carbohydrates, the proteins, the lipids, nucleic acids, and the enzymes. And what's specific about macromolecules is that they are high molecular weight biomolecules that are found in nature, and they're basically polymers. So carbohydrates are polymers of monosaccharides, lipids are polymers of normally they are polymers of glycerol and fatty acids, proteins are polymers of amino acids, the nucleic acids are polymers of nucleotides, while enzymes are basically complex proteins which perform a specific function. So today, in introduction to the drugs, the key concept which we will study are what do we mean by the term drug. So what are drugs? Second, we will try to differentiate between what's the difference between a drug, a medicine, and a poison. Then we'll see that how can we classify drugs and what are the various sources of drugs. Right. So let's start with the introduction. Right. So what's medicinal chemistry? Medicinal chemistry is application of chemical research techniques for the synthesis of drugs. Right, let us see what do we mean by drugs. So normally in common language, when we use the term of drug, it means narcotics. But in medicinal chemistry, when we use the term drug, it is in some different reference. Right. So during earlier stages of medicinal chemistry development, the scientists were primarily concerned with the isolation of medicinal agents. So here we known as medicinal chemistry or development, and medicinal agent, it means the medical industry. So in the earlier stages of medicinal chemistry development, so scientists primarily were concerned for isolation of medicinal agents which are normally found in plants. But today, the scientists are equally concerned with the synthesis of new compounds as potential drug, and also they try to improve the method of synthesis of existing drugs. Right, so in the previous time there was much more concern about how to isolate the medicinal agent from the plant, but the isolation of material from plant is costly. Secondly, the material we obtain is highly impure, so a lot of expenses and a lot of efforts are utilized in purifying that isolated material. Thirdly, the isolated material that's obtained in pure form is in very low yield. So overall, isolating some medicinal agent from plants, that's a very expensive task. So today, instead of isolating the material agents, scientists are looking forward to the synthesis of new compounds as potential drugs. Also, the concern of medicinal chemistry is to synthesize new compounds and to synthesize the existing drugs with improved methods, so that the method is of low cost. And if the synthesis scheme is of low cost, then the drug that will become available, that will be also of low cost. Right. So this is basically the concern of medicinal chemistry. Right. So when you use the term of medicinal chemistry, right, the medicinal chemistry don't work alone. Right, because it's a very broad aspect. So medicinal chemistry work with a team of scientists from different disciplines. For example, the team of medicinal chemists include the biologist, and these biologists will confirm about the type of species you're isolating the material from. For example, if you are looking for research in plants, then they will also carry out some testings whether a compound you have studied or isolated has some activity or not. Then we have toxicologists. So the purpose of this toxicologist is to study the toxicological studies and to see if these materials you have synthesized or you have isolated, are they have minimum toxicity or not. Then we have pharmacologists, then we have theoretical chemists, also they are known as the computational chemist. Then we have microbiologist and biopharmacist. So all of these, they work together and use sophisticated techniques to synthesize and test new products and to develop the most cost-effective and eco-friendly method of production of these medicines, right? So medicinal chemistry is a very complex and very broad field that involves many people at a time. So medicinal chemistry deals with the study of existing drugs, whether they are synthetic or they have been isolated from nature, and also involves the synthesis of new ones. And this also deals with the study of biological properties of these compounds, which are either existing in nature or you have synthesized them yourself, and it deals with the structure-activity relationship, right? So this topic of structure-activity relationship we will discuss in much more detail in the forthcoming lectures, right? So you should know about the medicinal chemistry, that it is dealing with the already existing drugs, the ones which have been newly synthesized, and considering their biological activities and study of their structure activity relationship, right? The next comes a topic that's very much important for being a medicinal chemist. So the term drug, which normally we use in our daily lives, mean narcotics, right? So but in medicinal chemistry we treat it as a different thing. So in a very broad definition of a drug is anything that include all chemicals other than food that affect living processes, right? So I repeat that a drug is anything or any substance that include all chemicals other than food, right? So food is not included in the drug. So other than food, all chemicals that affect a living process. So such a substance or such a material or such a thing is called a drug, right? So that includes the positive effects as well and negative effects as well, right? So if a drug helps the body, or it may be or is used for diagnosis, prevention, treatment of symptoms, and cure of disease, then this drug is called a medicine. While a drug that causes a harmful effect on the body, then that drug is called poison. So you can see that the same drug, the same material, that can be drug and that can be medicine, that can be poison, right? The same chemical that can be medicine can be poison as well. So that depends on the condition of use and the person using it. For example, if you're sick and you're taking a drug, then that's a medicine for you. But if you are not sick and you are taking a medicine, then that medicine will cause a harm on you, right? The same medicine, right, that is a medicine. The same thing that's a medicine for a person who is sick is a poison for a person who is healthy, right? Similarly, certain poisons, if they are taken in very controlled amount, they can help the body. So this term of medicine and poison sometimes becomes so confusing that instead of using the terms of medicine and poison, we call them as drug, right? So the purpose of using the term drug is to avoid the confusion between medicine and poison, because under certain conditions a medicine can become a poison, and a poison can also be used as a drug or as a medicine. So instead of using the terms of poison, or instead of using the term of medicine, we use the term of drug. And broad definition of a drug is that all chemicals other than food that affect the living process. So that effect may be positive or that effect may be negative as well. Right, so another thing which becomes important is we should know about the difference between a side effect and a toxic effect of a drug. Right, so as we mentioned earlier, the drugs we are using is a very flexible term, so that's considering all type of effects on it. So here we are considering the drugs which actually are not harmful to our body, right? The drugs that have a positive effect on body, right? So in this context, we are using this term of drug. So all drugs or all medicines have the potential for producing more than one effect, right? So the unavoidable adverse response of a drug appearing at therapeutic dose is known as effective dose is known as the side effect or secondary effect, right? For example, your doctor, your physician recommends that you have to take this medicine 3 times a day, right? So the dose which is being recommended, which is effective dose, right? So this dose will help you to overcome the disease. So this dose, this therapeutic dose, is known as the effective dose, and the effective dose is known as ED50. Right, so let's elaborate the ED50 thing a bit more. For example, suppose you have some test animals and you are testing your substance, or you're testing your drug on them to check if this drug if this compound is helping the animals or not. So if the concentration of the drug is that 50% of the animals are cured. Suppose you have 10 animals and at least 5 of them get cured, then that concentration or that dose of the drug is called the therapeutic dose or the effective dose, right? And it's called ED50. 50 means 50% population have been cured, right? So now we come back to our side effect, that your physician says that you have to take this medicine 3 times a day, right? And that will cure your supposed fever, right? That will treat your fever. So when you take this medicine 3 times a day, so you get rid of fever, but you develop some allergy, right? And the doctor says that you will get some allergy, right? It is unavoidable, right? So this medicine is also treating you, but it has some additional effect as well, and that effect which is unavoidable, because if you reduce the concentration of the drug, so your fever will not be treated. So you have to take that concentration, but with that concentration or with that dose of the drug, there are some unavoidable adverse responses. So these unavoidable adverse responses of the drug are termed as the side effects. Also, it's important to note that sometimes the unavoidable response of the drug may be helpful as well, right? So that's why we call them a secondary effect, right? So unavoidable responses of the drugs other than what it's meant for. For example, if a drug is meant to treat a fever, then instead of treating, along with treating the fever, this is also causing the loss of inflammation. That's helping you to get rid of inflammation. So this is also a side effect, but instead of calling that a side effect, we call as a secondary effect. Similarly, the unavoidable harmful effect of a drug, right, and that's appearing at the therapeutic dose, this is known as the side effect, right? So in contrast with this, right, so the adverse effects of a drug appearing at adverse dose, extreme drug dose, as it's called, toxic effect. For example, so you have recommended 3 doses of a drug by your physician, but instead of taking 3 doses, you get the 6th dose, right? So you are taking the drug in very much excess, right? So you are taking the drug at extreme drug doses. So this is called the lethal dose, right? So those effects which are appearing at extreme high doses are known as the toxic effects, right? That's the difference, right? So side effects are unavoidable. You have to get them, because if you reduce the concentration, then your treatment for a certain disease cannot be taken place. But in case of the toxic effect, you are taking the medicine in excess, right? So here we get another term which is known as the lethal dose, or LD50. Again, so when the biologists are checking for the toxicity, they give different doses to their test animals. So again, we are considering that we have suppose 10 animals and we get them different doses of a drug, right? So the concentration of the drug at which the 50% of population either die or they face some harmful effects, right, then that dose is called the lethal dose, right? So ED50 was the effective dose at which the 50% of the test animals were cured, while the lethal dose is called the LD50, and at LD50, 50% of the population, they suffer the consequences of the adverse effect of drug, right? So when you take the drug at very extreme high doses, then the adverse effects you face are known as the toxic effects. While if you are taking the therapeutic dose, then the unavoidable responses of the drug, they're known as the side effects. So these side effects may be adverse or they may be helpful. So if the side effects are helpful, then we don't call them as side effects, we call them as secondary effects. So you should know about these three terms. So what's the difference between a side effect, a secondary effect, and a toxic effect? I hope you are clear about that. So next we go to the classification of drugs. Right. So drugs can be classified on various bases. So basically there are 4 criterions on which we can classify the drugs. Number 1, drugs can be classified on the basis of their source of origin. Then they can be classified on the basis of their therapeutic use, means for which condition they are being used for, then the site of action, and drugs can be classified on the basis of their chemical structure. Right? And it's important to note that each drug can be classified into one or more of these drug classes. For example, if a drug is placed in a certain category on the basis of source of origin, then on the basis of site of action that can be placed in another category as well, right? And on the basis of chemical structure that can be also member of some other category. So each drug can be classified into one or more of these classes. So firstly, we will see that the classification on the basis of source of drug or on the basis of origin of drug. So drug can be either obtained from natural sources or they may be synthesized in the laboratory, right? So if they are synthesized from laboratory, they can be again 2 things. They can be semi-synthetic or they can be synthetic, right? So we'll consider all of these types of drugs on the basis of their origin separately. So firstly we will consider about the synthetic drugs, right? So most of the drugs that are available in the market nowadays are synthetic in origin, means they are synthesized in the laboratory. So such drugs are chemically pure, they are readily available in the counter, and they are 100% prepared in a chemical laboratory by using chemical reagents. Right? So they are not the use of any natural substance or anything. So these drugs are 100% prepared in the lab. So those drugs which are prepared in the laboratory, right? So these drugs are called synthetic. So these are extremely pure. These are readily available, and normally the synthetic drugs are inexpensive. They are cheaper, right? They are available at low cost. So examples of synthetic drugs include the aspirin, paracetamol, chloroquine, ethyl salicylic acid. Then we have chlorpromazine and ephedrine, etc. So all of these drugs, they are synthetic because they are prepared inside the laboratory. So we have now semi-synthetic drugs. So these are a bit different from the synthetic drugs. So for example, let's consider the semi-synthetic drugs. In some cases it happens that especially with some complex molecule, the synthesis of drugs may be very difficult or expensive or uneconomical, right? So you have to synthesize a drug, and the problem is that the drug has a very complex structure, right? And it's very difficult to prepare such drug, and not only it's difficult, but it's also very much expensive. So what we do is that we carry out a semi-synthesis or partial chemical synthesis. So in this type of synthesis, what we do is that we use a chemical that is existing in nature. For example, it can be obtained from plant material, it can be obtained through a certain cell culture, it can be obtained through a bacteria as well. So these material that are existing in nature, we use them as starting material, and we carry out some small chemical reaction with them, right? So since the chemicals, since the drugs, or since the material that are obtained in nature, so they are very much complex, so carrying out simple reaction will not be much difficult with them, right? So in semi-synthesis, what we do, we use the starting material, which is a complex molecule, and that complex molecule is obtained from nature. right? So this naturally occurring complex molecule is then undergone some simple chemical reaction that will lead to formation of drug of interest. For example, a very classical example in this specific case is the example of 6-amino penicillinic acid. Right, so you can see the name of penicillinic acid. You can just imagine where it came from. Right, it came from the penicillin. So 6-amino penicillinic acid is a semisynthetic drug, and it involves the precursor, which is penicillin, and that penicillin is actually isolated from a fungus, Penicillium chrysogenum. Right, so what we do, we take this fungus, Penicillium chrysogenum, and we get the penicillinic acid from this fungus, and we carry out simple amination reaction with that. Right, just see that we have taken a complex molecule from this fungus and we have just carried out a simple amination reaction with that, and we have got a complex 6-amino penicillinic acid. Right, so this way, since we have taken the reactant from nature, right, so this type of drugs that will be prepared will be called as semisynthetic drug. Now, we have another category which is known as the biosynthetic drug. Right, so there are several drugs that are very complex polypeptides. So you should know what are the polypeptides. So proteins are known as polypeptides. And why they're called polypeptides? Because they have many amino acids linked together through peptide bond. Right, so there are many drugs that are complex polypeptide, and it is very difficult to obtain these drugs in pure form from natural sources, and it's very expensive to carry out the synthesis of these drugs in laboratory. Right, so we cannot either isolate them from natural sources, and we cannot synthesize them as well. So what we do is that we use the biosynthesis, or also known as biogenesis, or also known as anabolism. Right, so this is basically enzyme catalyzed process, and in this process the enzymes cause the substrate to be converted into a complex product. Right, so you can make use of enzymes, or you can make use of engineered microorganisms such as bacteria. Right, so we use the enzymes, or we use these microorganisms to prepare those complex molecules for us. For example, human insulin. So human insulin is basically synthesized by means of bacterium. So what we do is that we insert a gene into the bacterium, and because of that gene, the bacterium start producing the insulin. So we are not synthesizing it ourselves, but we are using the nature to synthesize it for ourselves. Right, so in biosynthesis, either we make use of some microorganisms such as bacteria, or we make use of certain enzymes to help us prepare the complex structures, the complex drugs, which cannot be either isolated from nature, or they cannot be either synthesized in a laboratory. So examples of such biosynthetic products which cannot be isolated or synthesized in laboratory, so these include the human insulin, the interferons, the erythropoietins, and we have hepatitis vaccine. So all of these are either obtained from some microorganism or by use of certain enzymes. Okay, the next class on the basis of the source of origin of drug, these are the natural drugs. So as the name reflects, these are obtained from natural sources. So you can make use of plant-based sources, or you can have animal sources, or you can have some microorganism, or you can have some mineral from which a drug can be obtained naturally. Right, so we'll see step by step. So plant-based drugs are the drugs that are isolated from various plants. Right, and such drugs are still part of standard therapy. So these plant-based drugs are still used still in today's modern world as well. Right, and most of these don't have any synthetic substitute. For example, vincristine. So vincristine is actually a plant-based drug. It is isolated from plant, and still there is no medicine other than vincristine. Right, so it has no substitute. Similarly, Taxol, dioxin, quinine, zopine, ergotamine, ephedrine, colchicine. Then all of these are plant-based medicines, and the important thing about that, they are still used as medicines, and most of them have no alternative. There is no substitute for them. Then the next category of naturally occurring drugs are the animal sources. So some modern drugs continue to be derived from animal sources because their synthesis in laboratory is very expensive and very much difficult. For example, gonadotropins. So gonadotropins are actually obtained from different animals. Similarly, heparin, insulin. So as you know about insulin, so insulin was previously obtained from pigs. Then we have thyroid extracts and enzymes. So all of these are examples of the drugs that are occurring in nature, and they are obtained through animals, right? So next we have microorganisms. So they are another category of naturally occurring drugs. So microorganisms came into use for medicinal chemistry since the accidental discovery of penicillin from a mold. So mold is basically a word for fungus, right? So penicillin was actually accidentally discovered from the Penicillium chrysogenum, and since its discovery, so the chemists become aware that microorganisms can also produce some useful chemicals, right? So after the discovery of this penicillin, a large number of antibiotics have been discovered from a variety of soil fungi and some bacteria, right? So these drugs form most important group of chemotherapeutic agents. So example are penicillin, streptomycin, and tetracycline, right? So all of these are basically the medicines that are obtained from the microorganism. So you might be confusing, you might have some confusion about the biosynthetic drugs and the drugs that are obtained from the microorganism. So in biosynthetic drugs, what we use, we take the help of microorganism to prepare our drug, or we make use of enzymes to help us make a drug. But in the drugs that are isolated from microorganism, we actually get the drug from microorganism, right? The microorganism already preparing that thing, and we take the thing from the medicine. For example, the penicillin chrysogenum is already preparing this penicillin, and we are taking that penicillin from it. Similarly, some other fungi or some other bacterium that's preparing streptomycin, and we extract the streptomycin from itself. But when we use the microorganism to prepare a thing of our interest, right? So we are giving it some gene, or we are using the enzymes of that microorganism to help us make our thing of interest, then that's called the biosynthetic thing, right? So this is the difference between the drugs that are prepared through the biosynthesis and the drugs that are isolated from microorganisms. Then the last category of the naturally occurring drugs are the minerals, or minerals containing medicated springs. So there are certain springs that have been known to have some biological effect, and it has been linked that certain springs can can cure any medical condition. So these use of minerals or mineral containing medicated springs have been in use since time immemorial. So the medicines of medical value include the iron, calcium, magnesium, aluminum, sodium, potassium, etc., and they are of special interest to the medicinal chemist. So this is all about the classification on the basis of sources of drugs. So among all of these, the synthetic drugs are used widely. And why? Because they are very much inexpensive. It is easy to control their quality because it's in our hand. We are preparing them ourselves. So it's easy to control their quality, and we can produce them in larger quantities. So we can carry out their mass production, and because of therapeutic efficacy, right? So since this is all in our hands, so it is very much cheaper method, and the medicinal chemists mostly focus on the use or designing of synthetic drugs. Right, so classification on the basis of therapeutic use, right? So what do we mean by therapeutic effect? Therapeutic effect means the effect caused by medicine that helps to reduce the symptoms, right? Therapeutic effect helps to manage the symptoms of a disease. So it doesn't mean that we are curing the disease, we just causing the symptoms to disappear. For example, fever can be because of some underlying disease, but the medicine we use for fever, they just get rid of the symptom of fever, that's high temperature. Right? So medicine we used for fever because they have therapeutic effect, what they do is that they lower the body temperature. So they are managing the symptom, but they are not looking for the underlying cause. So what is causing the fever? Therapeutic effect is not linked with that. Therapeutic effect only studies the management of symptoms, right? So on the basis of therapeutic effect that's produced by a dose, by affecting the normal process of our body. So drug can be classified into large numbers. So just a few are mentioned here, just for your sake. So firstly, we have antiarrhythmic drugs, right? So antiarrhythmic drugs are used to suppress the abnormal rhythm of heart, right? The abnormal rhythm of heart is called cardiac arrhythmia, right? A means absence and rhythm means rhythm. So heart has a certain rhythm, right? So if that rhythm becomes abnormal, right, that's called the cardiac arrhythmia. The drugs which are used to cure this cardiac arrhythmia, they're known as antiarrhythmic drugs, right? So cardiac arrhythmia or abnormal rhythms of the heart include arterial fibrillation, atrial flutter, ventricular tachycardia, then we have ventricular fibrillation. So all of these come under this wide category of drugs known as the antiarrhythmic drugs. The next category we have anti-anginal, right? The angina means chest pain. So those drugs which are helpful in reducing this anginal pain are called anti-anginal. The next is vasodilator. The drugs that can dilate the blood vessel are known as vasodilators. Antihypertensive drugs affect reducing hypertension, right? Cardiotonic drugs help to increase the efficacy of contraction of the heart muscles. Then we have hypocholesteric agents, so as the name reflects that they help in lowering the cholesterol level. Anti-allergic agents are effective against allergy. Then drugs acting on GIT, right? So if you have facing the problem of constipation or you're facing the problem of diarrhea, etc., so the drugs you will be taking will be drugs that act on the gastrointestinal tract. And drugs that affect the renal system, the word renal means kidney, right? The drugs that affect the kidneys are known as drug affecting renal system, and drugs that act on central nervous system. And then lastly we have drugs that act on peripheral nervous system. So the difference between central nervous system and peripheral nervous system is that central nervous system only consists of your brain and the spinal cord, right? So the drugs that will act on either the brain or the spinal cord, they are known as drug acting on CNS or central nervous system, while peripheral nervous system means the nerves that are originating from the spinal cord, right? So any part of the nervous system other than the brain and the spinal cord is called peripheral nervous system, right? For example, if someone gets paralyzed, then it is the peripheral nervous system that has to be checked, right? So then we will be using drugs that act on the peripheral nervous system. You should know the difference between this central nervous system and the peripheral nervous system. Next, we have the classification on the basis of site of action of drug, right? So depending on where the drug is acting, so if the drug is acting on your heart, then the site of action is your heart. If a drug is acting on your renal system, in your kidney, then site of action is your kidney. Similarly, a drug, if it is acting on CNS system, for example, a CNS depressant, so CNS depressant will act on CNS, means central nervous system. However, this system of classification has a very big limitation because, as mentioned earlier, that drugs act on more than one site, right? In other words, we can say the majority of drugs have effect on several body sites, right? For example, CNS stimulant, which is cocaine, has also local anesthetic effect. It means it also reduces the pain, right? So it means if we classify a drug on the basis of site of action, we cannot be specific, because if a drug is stimulant of central nervous system, it's also acting on some local area as well. So it becomes very confusing whether we have to classify it as CNS stimulant or we have to classify it as local anesthetic, right? So this classification on the basis of site of action of drug, right, this classification is not of much use and it's not normally preferred. Right, so on the basis of the chemical nature or the function present in the drugs, the drugs can be classified into various categories. So these include hydrocarbon based drugs, then we have halogenated compounds, then we have alcohols, the drugs that have alcoholic group, they are known as alcoholic drugs, then we have carboxylic acid drugs, then we have phenolic drugs, then we have the drugs with nitro compounds, and the amide drugs, and sulfonamide, and amines, and sulfones, and stilbenes, and thiourea, etc. Right? So this is classification on the basis of chemical structure, depending on which functional group or which chemical moiety is present in the drug. So that's all about today's lecture, in which we saw about what do we mean by a drug. So drug is anything that affects on a living system. So this effect can be positive and this effect can be negative. So if the effect is positive, we call the drug as medicine, and if the drug is negative, then we call the medicine as poison. Further, we saw that since the use of these terms becomes sometimes confusing, so instead of using the term medicine or using the term poison, we use the term as drug. Then we saw different types of drugs. So we classified the drugs on the basis of their site, on the basis of their source of origin, as the synthetic drugs, semisynthetic drugs, biosynthetic drugs. Then we saw about naturally occurring drugs. Then we classified the drugs on the basis of their site of action. Then we classified the drugs on the basis of the therapeutic use. And now we have classified the drugs on the basis of the function group that is present in the drug. Right? I hope you have everything clear in your mind. So that's all for today. Thank you.